What's up, everyone? We are back with our final Tesla mechanical design engineer interview question solved. So today's problem we're going to break down into 4 steps. Step 1 is review the problem. Step 2, find our equations to solve the problem. Step 3, attempt our solution. And step 4, review the solution we came up with. Kicking it off with step 1, the problem states an engineer has designed a part which can be manufactured using 3 different processes. The part is nominally 10 millimeters with plus or minus 1.5 millimeter tolerance. Which manufacturing process will produce the highest percentage of in-spec parts? And then the problem says, note, C sub pk is equal to the min of USL minus mu over 3 sigma and mu minus LSL over 3 sigma. So I'm guessing that this is an equation that we're going to need to use. As part of part 1, we'll note this equation. C sub pk is equal to the min of USL minus mu over 3 sigma and mu minus LSL over 3 sigma. And what this is the process capability index. This is a measurement which can tell us which process will produce an output that's within our tolerances. In this, we have USL, mu, LSL, and sigma. USL is our upper specification limit. This is given in the problem. LSL is the lower limit, which is also given in the problem. Mu is our average, and sigma is our standard deviation. So our unknowns in this are mu and sigma. So we need to find those things. Let's move on to part 2, identifying the equations. Mu is equal to the sum of the entries in the data set that we're looking at divided by the number of entries. And sigma is our standard deviation. To find sigma, we're first going to need to find our variance, which is the sum of our entries minus our average squared. Now, to find our standard deviation, we will take the square root of our variance, which is equal to sigma squared, and divide that by n, our number of entries. So, standard deviation is equal to the root of sigma squared over n. Let's start off by doing this for A. First, we're going to find the average. Here you can see the calculations for finding the average. You add up all of the parts in A and divide by 5 the number of parts, and our average is equal to 10. Next, let's find the variance. Again, we'll find the sum of all of our entries, but this time minus our average squared. So we do that. And finally, we can calculate our standard deviation by taking the square root of our variance and dividing it by n, which is our number of entries. So our standard deviation for part A is going to equal 0.2828. Now, you saw how I did those calculations for part A, so I'm going to speed up parts B and C, and you can work through those on your own or slow down this video if you want to see how I did it. Great. We found that the standard deviation for part B is 0.22059 and the standard deviation for part C is 0.0748. Now that we know the averages for each part, the standard deviations for each part, we can plug all of these into our process capability index equation. So I'm going to set up a table with our process capability index and process A, B, and C. And you can see that the min for A is going to be 1.76, the min for B is going to be 1.52, and the min for C is going to be 0.80. So our process capability is equal to the min of 1.76, 1.52, and 0.80. That's all for this one. If you found a different solution, please leave a comment below. And please like and subscribe. This was the final video in the Tesla Engineer Interview Question series, so I hope you enjoyed this series, and I'll be trying out some different things going forward. If you have any suggestions, please leave a comment.